In this video, I'm going to explain how to read numbers off of the equipment that you are going to use. This is in the Unit 1 Metrics and Measurements Google Slides, but there's no section in the notes to copy anything down for this. If you wanted to write stuff down, you could on a piece of paper or something like that, but really what I want you to do is pay very close attention to this because it's easy to make mistakes, and once you understand the concept, it's going to be very easy to do this regardless of what equipment I give to you. You just have to stop and think about what you're doing before you start writing down numbers. So the first example here is how to use a ruler. Now it doesn't tell you what kind of ruler this is, but I think this is a centimeter ruler. And when I first look at a piece of equipment, before I start writing a number down, I want to look and see what each of these smallest lines means. What does each of the smallest increments mean? You could say, what is the resolution of the equipment? Really, it's what does each little line count as? And right here, I'm going from 3 to 4. And there's a bunch of little lines in between. And if you count them up, what's happening is each little line counts as 0.1. So that's 3.1, 3.2, 3.3, 3.4, 3.5, and so on. So what I'm doing is I am trying to figure out what the resolution of the equipment is. And when you are using equipment, when you're reading numbers off of the equipment, and again, I don't care what the equipment is, you always have to guess one place past what is actually known off of the equipment. So in this case, what I'm saying is what is actually known is down to the tenths spot, because each little line counts as a tenth. Now what you're going to see when you're doing this is that whenever you measure anything, there's always a little bit of guesswork, and that last digit in line is always going to be the estimated digit. Now for this, to me it looks like it's ending right before the 4. So the way I recorded my number is 3.97 centimeters. Right, so you know with certainty the 3.9 part, and you take a guess at the next number in line. Now, maybe someone thought it was 3.98 or 3.99 or 3.96 or 3.9 whatever. As long as you have 3.9 and some kind of guess here, you're going to end up getting it right. Now, it's a little blurry. If people thought it was right on the 4 and they wrote 4.00 centimeters, that would also be fine. Where you're making a mistake, though, is if you just write 4 or 4.0. Because if you write a lab report or something like that and somebody reads that, you are not accurately showing what type of equipment you used. So really what's going on, remember, each little line counts as a tenth spot, which is this spot right here with the 9. You always have to guess the next number in line. And since the next number is a guess, you get some leeway with that. Just because I think 3.97 doesn't mean you have to have 3.97. That last digit might vary a little bit, and that's okay. There's no reason why my guess is any better than your guess. All right, so now for this one, it says centimeters here. Again, each line is counting as 0.1. So you have 7, 7.1, 0.2, 0.3, and so on. So for this one, again, it's counting for the tenth spot. So I have to guess the next digit in line. Now, for this, it looked to me to be a little bit past this 0.1 spot. So I just took a guess and said, I think it's 7.15. Now, if you thought it was right on that 7.1, that's fine, but you have to write it as 7.10. Remember, this last digit can vary, but you have to have it there. And the way you figure it out is if each line, each little line counts as a 0.1, you guess the next digit in line. All right, so here's some real examples. So just try and think about this for a second before I say it. See if you can come up with an answer. So you're working with centimeters here. Each line counts as 0.1 again. So it's 2.1, 2.2, 2.3, 2.4. So I know it is somewhere between 2.3 and 2.4. So I take a guess, and I say I think it's about halfway. So I'm saying 2.35 centimeters. All right, same kind of thing down here. Now I'm less than 1. So it's 0.1, 0.2, 0.3, 0.4. It looks like it's between 0.3 and 0.4. To me, it looks to be a little closer to the 0.3 range, so I'm going to say 0.33 centimeters. If you were thinking 0.31 or 0.32 or 0.33 or 0.34 or whatever, or 0.30, I would accept all of those. Technically, you should be able to see that it's a little bit past 0.30. But if you have 0.30, at least you're including that last digit. So I know you're looking at the resolution of the equipment the right way. All right, graduated cylinders are something that we would use a lot if we were in school and doing labs. So it might come to the point where I just show you pictures of graduated cylinders with stuff in there for labs, and you can measure it. When you're reading a graduated cylinder, you want to keep your eye level with the meniscus. The meniscus, it has to do with surface tension. Most liquids form this downward curve, and you read at the bottom of the meniscus. You want to keep your eye level with it, because if your eye's too high, you'll get a reading that's lower than it should be. And if you're looking up at it, your reading is going to be higher than it should be. You want your eye level with it. All right, so for example, same thing as what we did with the ruler. Figure out what each little line means on that device. So I'm going from 30 to 40. So each line counts as 1 milliliter. This is 31, 32, 33, 34, 35 milliliters, 36, 37. I know it's somewhere between 36 and 37. I said 36.4 milliliters. Now I intentionally put that down because I have I'm guessing a lot of people probably said 36.5. And the only reason why I put 36.4 was to demonstrate that the numbers can vary a little bit. All right, 36.4 is just as good as 36.5. All right, it's fine by me like that. That last number is a guess. All right, now for this one, it's going from 15 to 20. So you have 16, 17, 18, 19, 20. So each line is counting as a milliliter again. So you have to guess to the next number in line, which is a tenth. All right, so each number is counting as a milliliter. You guess the next number in line. Now you see how the meniscus is landing right on that. You still have to put that guess in. You should guess it as 19.0 milliliters. All right, you guessed the next digit in line. So the 1 and the 9, the 19 was known for sure. It landed right on it. Now, those are the ones that are really, really easy to forget to do, and it lands right on the line. If you're going too fast, it's very, very easy to mess that up. The first example, a lot of times when it's between lines, it's really easy to remember, like, oh, I have to take a guess there. But the next one, that middle one, is a little more difficult. All right, now this one, again, look at the scale first. Before you even try and figure out the number, look at what the resolution of the equipment is. So now I'm going from 6 to 7 milliliters. So this is 6.1, 6.2, 6.3, and so on. So I'm somewhere between 6.2 and 6.3. So I have to take a guess at where I am between those, and I'm thinking it's 6.25 milliliters. I said I thought it was just right in the middle there. Right, so since each line counts as a tenth, which is this where the number 2 is, that spot, I have to guess the next one in line. All right, now here's a graduated cylinder, a little more what it would look like in the lab. Again, before you start writing a number down, figure out what each line means. So this is going from 10 to 20, so each line counts as 1 milliliter, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, so on. So it's counting as 1 milliliter, so you guess the next digit in line. So to me, it looked like that meniscus landed right on that 17. So I said 17.0 milliliters. You want to make sure you include that 0.0. It's letting people know what equipment you used, how accurate or how precise it was. All right, so that's what you want to do. Now, this graduated cylinder I know is really hard to see. The one on the left, this is a 10 mil graduated cylinder, and you're starting off, the number 1 is this bottom line here. And what happens is everything below that would just be less than 1, so you wouldn't be able to get a recording for that. So it goes from 1 to 2, so that means each line counts as 0.1 as the 10th spot. Now when I look at this picture on the right, the number that's cut off by the red plastic bottom part, that is the 1 milliliter, but you see the 2 milliliter up from that. So if I count these out, this medium length line would be 1.5 milliliters, right? Because you have 1, there's 0.1, 0.2, 0.3, 0.4, there's 1.5, 1.6, 1.7, 1.8, 1.9. So to me, it looks like it might be just above the 1.9. So I said I thought it looked like 1.92 milliliters. Right? If you said 1.90, 1.91, 1.93, stuff like that, that would all be fine. If I had a question on a test about this, I would not have, for example, if it was multiple choice, I would not have 1.91, 1.92, 1.93, and 1.94 as options. I wouldn't do it like that because technically all of those are considered correct. All right. A lot of times people call these triple beam balances. Technically they're quadruple beam balances because there's 4 beams, and I'll show you a picture of what they actually look like, but that's not the important part. The important part is reading it. What you want to do is add up all of these values to get the number. So this beam that's all the way in the back, you have this counterweight here, and since it's on the 0, it's basically telling you you have less than 100 grams. So I can ignore this back beam at this point because it's on 0. So I know the 20, I know the 8, so I can add those together. 28, that's the easy part. Now, you have to look at the resolution of this equipment. Notice I'm going 0.5 to 0.6. So each little line is counting as a hundredths spot. So this is 0.51, 0.52, 0.55. Wait, I said that wrong. Oh my God. 0.51, 0.52, 0.53, 0.54, 0.55, 0.56. Now, 0.57, it's kind of blurry the way this picture was. It looked like it's right on 0.57. So I'm going with 28.570. Right? Each little line counts as a hundredth. The hundredth spot is where that 7 is. So I had to guess the next number in line. You always have to include that guess. That is the big take-home idea with this video. Always guess the next number in line, even if it lands directly on the line. All right, here's another one. So I have 109. So 109, that's the easy part. The scale is the same. They're going up by hundredths. It looks like it's right between 0.07 and 0.08, right? Because this is 0.1. So that means this half line here is 0.05. This is 0.06, 0.07, 0.08, 0.09, 0.1. So I said I thought it looked like 109.076. A lot of times when people record this, they forget about this 0 and they just say 109.76, but that would be, all the way down here somewhere. It's 0.076 because it's less than 0.1. And I thought it's between the 0.07 and 0.08, so I took a guess at that 6. All right, this is what a triple beam balance really looks like in the lab. You can tell in this first picture on the left, top left, that the last counterweight is over the 0 part. The next one's over the 20, the next one's over the 9, so I know it's going to be 29 something. And now this bottom picture on the bottom left is a close-up of that. So what I end up doing is looking at this. It's between 0.3, well, the sliding scale is between 0.3 and 0.4, but when I look at it closer, this half line here is 0.35. This next line is 0.36. So it's somewhere between there. I said it looked to be about halfway, so I said 29.355. You always have to guess that next number in line. We know it's between 0.35 and 0.36, so I guess the 5 at the end. When you're using the triple beam balance, if we ever end up back in school, what you have to do is slide these counterweights until you get this thing, and it's hard to see the lines, those lines to match up, and that means you have it balanced the correct way at that point. All right, so remember the take home for today, you always estimate one place past what is known on the equipment. So for example, these little lines count as hundredths, so you estimate to the thousandths. That will do another time.